Hello, today we're going to learn about simultaneous equations with the need to balance the coefficient. Essentially, our lesson will be a continuation of our topic on solving simultaneous equations or finding the solution to a simultaneous equation. But this time we're going to have to work with equations without or with no common coefficients. So in which case we would need to balance the coefficients to be able to use elimination method. Just let's do a quick recap though of solving or finding the solution to a pair of simultaneous equations. In this case, without the need for balancing first, just to have a recap. So we suppose we have 5x plus y equals 22 and 2x minus y equals 6, right? So let's just establish that we're going to use elimination method. Okay, and in this case, we chose to use elimination method because it's easy for us to do that because we already have y with common coefficients. You can see y for equation 1 has a coefficient of 1, and then y for equation 2 has a coefficient of -1. In this case, we will add the equations so we can end up with the linear equation with one variable. So let's just write the step, add the equations. Take note that you can choose to whether to add or subtract the equation based on the signs of the coefficients that you have. Usually if the coefficient that if the variable that you want to eliminate has coefficients of the same sign, meaning they're both positive or they're both negative, you subtract the equation so you can cancel the terms out. If they have opposite signs, you add them. Okay, so that's what we're going to do with this pair of equations. So we have 5x plus y equals 22 plus 2x minus y equals 6. So you just add, so you basically just divide this into 3 sections and then you add them up. Okay, so 5 plus 2x is 7x. Now obviously y plus negative y is 0, so that gets cancelled out. You just cancel that way. And then 22 plus 6 is 28. Okay, don't forget the equal sign. And so your resulting linear equation, let's just in this case is 7x equals 28. Now you need to solve for the value of x, and so what you're going to do is divide both sides. So that's the second step. Okay, solve for the value of x, and so you divide both sides by 7. So 7x divided by 7 equals 28 divided by 7. Cancel that x, and x is going to be equal to 4. And so you already have one of the values for the solution. And now the next step would be to pick either one of the equations, either equation 1 or 2, and substitute x equals 4 for the value of x in there. So the third step in this case is substitute x equals 4 to either equation 1 or equation 2. In this case, I will choose equation 1. Okay, so use again, you can use either equation. Equation 1 is 5x plus y equals 22, so 5x plus y equals 22. Now if x is equal to 4, then 5 times 4 plus y equals 22. Therefore that's 20 plus y equals 22. Move 20 to the other side. Okay, so you will have y equals 22 minus 2. Oh, 22 minus 20, sorry about that. Okay, and y is equal to 2. And so that is your value for the y. Therefore, the solution is 4 and 2, or you can say x equals 4, y equals 2. Now you want to be sure that that's correct, so you perform a checking. And how do we do that? We substitute x equals 4 and y equals 2 to both equations. Oops. Both equations to see if they satisfy both of them. So let's try equation 1 first. Equation 1 is 5x plus y equals 22. And so this side of the equation must be equal to 22 as well to conclude that the solution satisfies this equation. So 5 times 4 plus 2 equals 22 gives you 20 plus 2. It's 22 equals 22. So that's correct. Now, work on equation 2, which is 2x minus y equals 6. So 2 times 4 minus 2 equals 6. 8 minus 2 equals 6. 6 equals 6. And therefore, our solution is correct because it satisfies both equations. Okay? And so now that's how you perform, again, the elimination method in finding the solution to a pair of simultaneous equations. In this case, we didn't need to balance the equations because, again, we have a variable that has the same coefficient. Okay? Now, what if we don't have a case like that? We don't have a case wherein any of the variables have a common coefficient. That's what we're going to work on today. Okay? So, suppose we have the example, that's example 2. Oh, I can't write there. Oh, there. Sorry. This one. Computer is lagging. Example number 2. Okay. Suppose we have 3x plus 2y equals 18, and then 2x minus y equals 5. Now, as you can see, we can't just add or subtract straight away because it would not cancel any of the variables. If we add it, we're just going to end up still with an equation with 2 variables. We'll still end up with x and y in the resulting equation. We don't want that. We want to end up with a linear equation with 1 variable when we're trying to eliminate. That's why it's called elimination method. So what we're going to do is to balance it first. So we add another step. Okay, balance a coefficient. Okay, now what does that mean? That involves multiply an equation by a number that will end up with an equation with a similar coefficient. Again, feel free to pause the video so you can copy things, okay, from the screen. So we're going to multiply one of the equations, let's name equation 1 and equation 2, so that we end up with at least one of the variables with common coefficients, okay? And in this case, I'm going to multiply equation 2, okay, by 2. So I'm going to write that down. Multiply why am I doing that? Because if I do that, so 2 times 2x minus y equals 5. If I multiply that, I'm going to end up with 2 times 2x is 4x. 2 times negative y is negative 2y equals 2 times 5 is 10. Okay? When I did that, I end up with a term that is 2y, which I can now just add, okay, Okay, I can now just add the new form of the equation to equation 1, and I can get rid of 2y. So that's basically the goal when you're balancing the equation. So you end up with something, a pair of equations that you can easily add or subtract to each other and end up with canceling one of the terms. Okay, so now you can proceed to step 2. In this case, since I have a positive 2y and a negative 2y, I will add the equations. To get rid of y. Okay, and so if I do that, we'll have 3x plus 2y equals 18. 2x minus y equals 5. I will add it. Okay, let's put a division, divide there so we don't get confused. Okay, so when I add that, I will get 3 plus, oh sorry, this is now 4. Okay, the equation 2 is now different. Okay, so equation 2 is now this one. You're gonna use this. Okay, 4x minus 2y equals 10. Okay, sorry about that. So you're gonna use the new form of the equation so you can cancel it. Okay, and so you're gonna have 3x plus 4x is 7x. Okay, and then 2y plus negative 2y is 0, so that gets cancelled out, and then 18 plus 10 is equal to 28. Okay, and so funny enough, we ended up with the same linear equation. We have 7x equals 28. So the next step will be solve for x. And now we're going to just have to solve for x by dividing both sides by 7. That's easy enough. X is equal to 4. Yeah. And now you just follow the same step. Oops. From normal elimination. Okay, substitute. In this case, I will substitute it to equation 2. Original equation 2. Okay, so the original equation 2 is 2x minus y equals 5. You can choose whatever you want, okay? Sometimes I choose the one that will make it easier for me to do it manually, okay? Because sometimes I don't have a calculator with me. So I'm going to have 2 times 4 minus y equals 5. Okay, 2 times 4 is 8 minus y equals 5. Sorry. So I'm going to end up, so if I transfer a to the other side, I'm going to end up with, so, sorry, that would be negative y equals 5 minus 8. Negative y equals 5 minus 8 is negative 3. Okay, but I'm not looking for negative y. I'm looking for the value of y. So I'm going to divide both sides by negative 1 to cancel the negative sign. And so y is equal to 3. And therefore, I say that the solution is 4 and 3. Okay, or x equals 4, y equals 3. Now, similarly, we do a checking just to make sure. Okay, so we check our solution to see if it satisfies both equation. So we do equation 1 first. Okay, equation 1 is 3x plus 2y equals 18. Oh, sorry. Pen is. And so 3 let's take my, what happened to my pen? Give me a sec.